Entrepreneurship Seminar organized by the Productivity, Innovation and Entrepreneurship Division in the OECD Directorate for Science, Technology and Innovation. My name is Flavio Calvino. I'm in charge of the Technology Diffusion team in the Productivity, Innovation and Entrepreneurship Division of SCI. And today I'm going to chair this seminar that invites distinguished economists and policymakers to discuss key challenges to economic growth that OECD countries are currently facing and inform the debate on effective policy responses. The seminar series is the result of a strong and long-standing collaboration between the STI Productivity, Innovation and Entrepreneurship Division and the Director General for Research and Innovation at the European Commission. So the seminar today is going to focus on the topic of techies and firm-level productivity. We are honored and very happy to have Ariell Reshef as our speaker today with us. Ariell is a research director at CNRS, University of Paris 1, Panthéon-Sorbonne, as well as an associate member of Paris School of Economics as a scientific advisor at CEPII. He specializes in international trade, technological change, and their impacts on the labor market, with papers published in top journals, including the Quarterly Journal of Economics, the Journal of Economic Perspectives, and the Review of Economic Statistics. His research has focused on changes in the structure of employment, income distribution, productivity growth, and innovation, on how regulatory changes affect labor demand and on wages in finance and legal intermediation. So before we begin, I would like to remind everyone of a few house rules. The event will be conducted in a virtual format. Attendees online are encouraged to ask questions through the Q&A feature in the Zoom application or the chat. Should you wish to speak online, you may raise your hand, and our technical team will assist in enabling your microphone. We also have several invited participants in the room. And if you wish to ask a question in the room, please raise your hand and click on the microphone button after being acknowledged. So with this, I'm pleased to announce that the welcome remarks to this seminar today will be delivered by Paul Cusson, who is the head of Industry Economic Analysis Unit in the Director General for Enterprise in the Ministry of Economics and Finance of France. Paul is also serving as a vice chair of the OECD Committee of Industry, Innovation and Entrepreneurship, the CIIE. Paul, thank you very much for being with us today. The floor is yours.
Thank you, Flavio. And I would like to start by thanking you and the OECD for the organization of this seminar and for giving me the opportunity to say a few words to open this seminar. I'm very pleased and honored to give these remarks to introduce the research that will be presented to us by Professor Reshef, who made notable contributions to the investigation of labor market polarization in France in a previous book that documented how France was experiencing job polarization between high-skilled, high-paid jobs and also on the other end of the spectrum, low-skilled, low-paid jobs at the expense of medium jobs. That line of study contributed to helping us understand how technology-related occupations, so techies, play a role in that polarization process, because the results that were found suggested that the distribution of techies across firms tend to contribute to the explanation of that specific polarization process. And this polarization appears to be driven in large part between firms' variations inside industries rather than by changes of industry structure or by within firm distributions of employees. So that firms that employed more techies appeared to grow faster than others. And so the paper that will be presented in an instant complements these results with new contributions to that literature and also to the literature investigating the determinants of productivity at the firm level, and in particular the role of techies. It leverages the very rich micro data sets that are produced by the French National Statistical Institute and that give a near exhaustive view of workers and their occupation by firm over time. I want to underline that this line of research is especially relevant for policymakers and policy analysts, such as myself, because it helps us understand several string and inclusive growth. First of all, it gives us a better understanding of the drivers of productivity slowdown that has been observed in advanced economies. In economies where the stock of labor and capital grow relatively slowly, productivity is key to have sustained growth. And so better understanding these determinants, especially those that pertain to technological change and innovation, is very valuable to help design effective growth-enhancing policies. And in the case of France, these results echo several stylized facts that we know about productivity in France, such as the fact that there is a lower level of information and communication technologies diffusion, or the fact that there is also lower innovation performance compared with other advanced economies. So addressing these challenges, we have implemented policies to foster adoption of ICTs and support research and development efforts. And secondly, these results also underline a double polarization phenomenon at the same time between workers and between firms, and the relation between them, because the gap between the most productive firms and the average firm has widened between the rest and the best, as a previous OECD paper has put it. And Professor Reshef's research documents that the presence of skilled techies plays a role in explaining this productivity gap. On the labor market, the rise of techies feeds into the polarization around high-skilled technical jobs, and these results tend to question the inclusivity of growth, especially in France, where we have seen a rising share of the population being paid around minimum wage over the last few years. They also echo the PISA OECD results bearing on the French educational system that have tended to show that the gap between the best performing students and the average student has widened over the last decade. So policy answers to these challenges about the inclusivity of growth have included reduction in class sizes, in struggling neighborhoods, development of vocational training, and programs aiming at promoting STEM education with students that tend to self-select out of these subjects, typically girls or underprivileged kids. Finally, I want to thank again the OECD for this seminar on a crucial topic, and for giving me this opportunity to make these opening remarks. And I now yield the floor to Professor Reshef to have a presentation.
Thank you, Paul. Yes, Ariell, you have about 45 minutes indeed. The floor is yours. There's going to be also time for Q&As at the end.
Okay, so I hope I hope everyone can hear me. Before I jump into the paper, I just wanted to make a quick remark on the question about polarization. It used to be very hot and hotly debated until recently. But actually, this phenomenon, and in particular in France, but not only in France, in most of Europe, has either slowed down or has vanished completely. So there was a period in time in which many European and broadly speaking OECD countries were experiencing this phenomenon of polarization. That was the topic of some research, and some of that culminated in the book. Actually, in a chapter that I've co-authored recently for the OECD with my longstanding co-author Farid Toubal, we actually document that this polarization is actually something somewhat in the past, and we're moving back to a more in the jargon of the economist jargon, more of a skill-based technological change dynamics as in the 80s and the early 90s. So I just wanted to comment that before I go into the next topic, which are these techies. So this paper is about these techies and productivity and growth. So the starting point of this project and this long-standing research agenda is that engineers and technically trained workers that we're going to call techies, think of these as technicians, people that have STEM education in general, are fundamental for growth, income, patenting. Some economic historians say that they're responsible for the Industrial Revolution. So some of these papers are very well known. The Romer paper about endogenous growth highlights the role of engineers. Papers papers like the paper by Maloney and Valencia Caicedo, I'm probably not pronouncing their name correctly, show that clusters across space where there were engineers in South America and the US, places that fostered engineering schools, seem to have higher income per capita and higher more technological savvy 100 and 150 years later after the fact. And the papers that I guess the common denominator is Yoel Mokir, that argued that the Industrial Revolution actually started north of La Manche, or the English Channel, depending on your point of view, because actually England had this broader base vis-a-vis France of available, basic, technically trained people that could operationalize blueprints, that could do basic math, that had good reading skills. And that was not, it didn't exist. It's not like it didn't exist in France, but the supply of that type of skill was much, much more constrained because of all kinds of institutional questions and so on and so forth. You can read these papers; they're very detailed in there. They give very rich institutional descriptions of these. So the point is that while some of the most famous innovators came indeed from England, it's not like there wasn't innovation following on their heels in France. In fact, there was quite a bit of that. But the diffusion happened much faster and in a much more profound way in England because of this system that allowed, in particular apprentices, that allowed this broader supply of people that could basically carry out technical tasks. Having said all that, all of this makes sense, but actually there's very little known about what these techies actually do in firms. Okay, so what this paper is going to attempt to do is to study the impact of these techies on firm level productivity. We're going to distinguish, using the rich French data, we're going to be able to distinguish techies along essentially, we can bin them into 6 categories, essentially: R&D, ICT, and other tasks, and a higher level and a low level. So think of this as engineers and technicians. And importantly, we're going to show that their role extends beyond manufacturing and exists and is actually quite large, also in the non-manufacturing sector. And I'll give you some more details on that. This is important because a lot, I would say, well over 90% of the literature on productivity growth, innovation, all that is squarely focused on manufacturing. There are a lot of good reasons for that, but we know that manufacturing is a small and shrinking part of the economy, certainly in employment, in some countries even in value added. So, jumped one too many. Okay, there's some delay. So we're not coming completely out of the blue to this topic. There is some literature on techies, technology, and firms. So there are papers by Tambe and Hitt, Deming and Norrie that indicate, although don't show it in a structural way as we do, that indeed these techies are key workers in implementing new technologies and technology diffusion and spillovers and so on. Importantly, the word innovation or R&D doesn't appear in this bullet point, and that's actually not an accident. Okay, you will see that we'll hark on this theme as we go along. This is the previous paper that part of it is contributing to this book that was mentioned. Techies are associated with employment growth. There's a long literature on R&D and the relationship between R&D and input and innovation, typically measured by patents and output, which is not even productivity, right? So Hall, Meres, and Moen have a survey of this literature. Interestingly for us, there's this very interesting paper by Aurora, Belenzon, and Scheer that argue, although once again empirically it doesn't actually show this, that the quality of the corporate research in corporate research labs the quality of the research output in corporate research labs is tightly associated to the quality of researchers employed in this activity measured by academic citations. So they're looking at people that used to work in academia, moved to industry, and they measure their quality by by some measure of citation, what you can find on Google Scholar, for example, citation counts and so on. Now, we're also going to touch upon the literature. We're going to draw on the literature on firm-level productivity, measurement and estimation of what determines it. So Syverson and DeLocker, two of the leading figures in this literature, have argued that few papers actually address structurally what determines productivity. You'll see what I mean by structurally. Some attempts have been made. So Chiara has made a contribution. She has several contributions to this, but one of them, which is particularly important for our paper, is that knowledge spillovers are important for productivity growth within firms. DeLocker has a famous paper about learning by exporting. Doroshevsky and Jamadru highlight the role of R&D expenditures. Bloom and company tell us that management is the key to productivity growth. And today we're going to tell you that there's something more there, and perhaps more broadly based, which are the techies. So quickly, the summary of the paper. I think I timed the paper to be on time, the presentation, but what is the summary of the paper? So first I'm going to characterize for you what these techies are, because it's very important, because it's also going to motivate what we do later in the structural part of the paper. So what are techies? Techies are STEM skill intensive people. They're associated with innovation, technology adoption, and the management and diffusion of technology within firms. Importantly, not management in general, and I'll make that point more clear as we go. There's a part in the paper that I will not discuss. It's a theoretical framework. It's not very important for today, and we don't make a big contribution there anyway. And then the meat of the paper is really estimation of the causal effect of techies on firm-level productivity using state-of-the-art methodology. Okay, so what do we find in this part of the paper? While the first part of the paper is very descriptive, the second part tries to make much more of a causal statement. We find that techies raise firm-level productivity. This occurs both in manufacturing and importantly in non-manufacturing sectors. This effect goes well beyond R&D. So there's a lot of focus on R&D, and I'm not saying that it is not important, but if you're not at the frontier, or if you're not pushing the frontier, you may still need these techies in order to catch up with the frontier. They're important for the adoption, for the diffusion, for the education of the workforce within the firm. In non-manufacturing firms, in fact, the impact of the techies on productivity operates mostly through ICT. Our knowledge of what services are dovetails with this statement. And we also find that the effects, and speaks to Paul's comments before, the effects seem to be larger in more productive firms at the get-go. So bigger firms, or bigger, more productive firms, are where the same amount of techies, if you will, is going to have a bigger effect on future productivity. Maybe this is indeed the dynamic that increases the dispersion. Okay, so let's characterize. If there are no questions, please free to jump in. I'm used to academic seminars where it's you're lucky if you get through the first 3 slides without tons of questions. But I'm happy with this mode of operation as well. Okay, so who are these techies? So we're going to identify these techies based on 4-digit occupational classifications. Those of you that have worked with the French occupational classification know that since 2009, you can see very, very detailed occupational titles. There are 58 occupational techie occupations in total, and they're going to be classified into these 6 beans, as I mentioned before, okay? Importantly, the INSEE documentation clearly distinguishes management of technology from general management. So quality control, logistics, financial, all these other functions, they clearly, when we say management of technology, at least in as much as the classification is concerned and the guidelines that firms receive when they fill in the forms, indicates that this is not your typical Bloom and Van Reenen management people, okay? So we're going to match a bunch of data sets, okay? Some of the administrative data, the DADS. We're going to match into that data training and professional qualification data survey. We're going to have the R&D survey for France. I'm going to have the ICT survey from France, and each piece of these surveys and data sets is going to give us is going to enable us to shed a little bit of light on from a particular dimension on these techies. Okay? And this gives rise, as we summarize in the paper, in 5 facts. Maybe there are more than 5, and that's how we organize it. So fact number 1, where are these techies across industries? Okay, so this is basically coming straight from the DADES. There's no survey data. This is quasi-exhaustive. This is actually as close as it gets to quote-unquote reality. Okay, because there's no cleaning here. This is just raw data. This table comes really from the raw data. So where are so first of all, these techies are important in the economy. Okay, they're 18% of the wage bill, clearly a little bit less in terms of employment. And this has followed a positive trend. So despite what people may think about France, France is actually not that much of a laggard. It's not at the frontier, right, in terms of techie intensity in the economy, but it's not. It's like in many indicators, France actually shows up kind of like in the middle or in the upper part of the middle, right? So that's typical for a lot of OECD countries, and you know this better than me. 70% of these techies are not doing R&D or ICT. Okay, this is similar to what Barth et al. Find in American data. There's different methodology and different indicators, but what I'm highlighting here is that when I say techies, don't think about only people that do R&D or ICT, for that matter. Most of the R&D techies are indeed in manufacturing, and that's why it makes sense that if you're studying R&D, you're going to focus on manufacturing, because most of the R&D is, in fact, at least in terms of accounting standards, located in manufacturing. Most of the ICT techies are actually in the non-manufacturing sector. What we know about the non-manufacturing sector, the services sector, makes sense here, right? And engineers account for more than techies in terms of their weight, in terms of their employment, in terms of their wage bill. Okay. Techies are STEM intensive, so this is you don't need a leap of faith to believe this, but we actually go into the data and we show that 63% of the techies' highest degree is indeed a STEM degree. Okay. 20% of these techies also, in addition, have additional technical training. Okay, this profile is very rare in other occupations. In particular, the other managers, the Bloom and Van Reenen, the Bossonomics managers, very few of them actually have degrees in STEM. Okay, which indicates a distinguished technological role for techies over and above what the INSEE documentation actually implies. Fact number 3, techies are positively associated with the diffusion of ICT. So this is coming from the ICT survey. So we find that firms that give particular ICT training to their employees is kind of rare, maybe a fifth. But techies the presence of techies in the firm is strongly associated with these programs. And this is especially true. It's comforting that we don't find this strong association for all classes of techies. It's particularly strong for where we think it should be for the ICT techies. So firms that have particularly ICT techies are the ones that are going to give much more of this training to their workforce. Most of the R&D spending is on wages and occurs in-house. You'll see why that's important for econometrics later. So the median share of externally sourced R&D services is 0. The median firm that does R&D doesn't externalize this, and the mean in particular on the positive support is only 9% of the total. So even when this happens, it's not huge. Of course, this is skewed, right? Some firms do virtually all of their R&D that is outsourced, but they're small and they're very, very few. Okay. The external share of R&D doesn't correlate with overall R&D. This is important because we're going to use this R&D concept very heavily later. Importantly for us, wages account for 3/4 of R&D expenditure. This dovetails with other surveys, data from the Crédit d'Impôt de Recherche, because we're going to use actually labor input as our indicator for R&D activity. Okay, so we're missing some, but maybe not the majority. And finally, techies are positively associated with patenting and innovation. Okay, as you know, patenting is rare. innovation actually is something that many firms do. 76% of firms in the R&D and innovation survey actually report innovation, but actually much fewer of them report patenting. Techies are strongly correlated with patenting, okay, especially the R&D techies. So we're not saying that R&D is not important. It's clearly important for patenting. But when you look at innovation more broadly, you have two types, product and process. You see that the R&D techies are strongly associated with product and process innovation. The ICT techies are actually not associated with the process innovation, but more with the product innovation. Since this is coming mostly from the services sector, you can imagine what kind of product innovation is occurring. And the other techies, you should think of this as maybe chemical engineers in the chemicals industry or things like that, or civil engineers in construction and so on. These people are strongly associated with the other type of innovation, which is process innovation. So all these things kind of like make sense. And on purpose, I put all these arrows in both directions because there's nothing causal here. This is purely correlational, but it's highly suggestive that the patterns actually make sense with what you think the roles of these different types of techies are. Okay? Yes, question. You probably need to push a button.
This one? Sorry if I missed it, but how exactly do you identify the techies?
So as I earlier said, the techies are coming, the identification of the techies comes from this data set called the DADS. It's a quasi-exhaustive data set that covers all of France. You can think of this, everything that happens in the formal sector needs to happen, will be recorded in the DADS or one of the smaller sister data sets. And we have occupational classifications for these people. I should have actually brought up a table that gives you a sense of these occupational titles. The classifications actually it's very easy to identify who are these techies. Right? Actually, the 2-digit level actually already tells you who are techies. So you have engineer, essentially what you can think of as engineers or cadre, okay, and technicians. So those are 2 occupational codes, okay, and within those codes we have this. We can classify people according to these 3 tasks. The occupational titles are indicative. If the title has R&D in it, and you're in if you're in PCS 38, and your occupational title, the text says R&D, I put you in R&D. If your title says ICT, I put you in the ICT, and all the rest go in the other bin. Okay. To be completely transparent, there are 2 occupational titles that are both R&D and ICT because R&D exists in ICT per se. We put this in the R&D. We've experimented with putting them in ICT. It matters it doesn't matter at all qualitatively. It matters a little bit quantitatively for the econometrics that we're going to do in a bit. Okay.
I also have another very quick question related to the very last bit, the last fact, when you matched with the CIS. I was wondering whether you looked also at this, whether there has been more a link with the new to the firm or new to the market innovations and the difference between, that might link with the difference between innovation and diffusion, and whether some techies are maybe more linked to the new to the market or the new to the firm. I don't know whether it's something that you have looked into.
So the short answer to that is no, but we probably should, and we can discuss later ways to enrich this analysis. One of the things that we want to do, in fact, is to actually do the entire separate paper, actually just looking at the CIS and matching the techies and just characterizing this even a more rich way. These facts are designed to help justify what we do later, but there's a lot more one can do. Okay, so the descriptive evidence seems to suggest that these techies are doing things that are potentially productivity enhancing, right? R&D, patenting, innovation, all that stuff is actually not productivity. One should distinguish. You can do a lot of innovation and it's junk, right? It doesn't add to productivity, the thing that we really care about. And so we're going to ask, does it actually increase firm level productivity? Now, this is a hard question because we don't see productivity. It's you need to infer it. And so we're going to take this production function estimation approach, and I'll explain a little bit more about how this works. And there's going to be one key assumption. This is a structural assumption that we're not going to back down from. And we cannot. I just want to be transparent on that. We're going to assume that techies affect output only through their contribution to productivity and with a lag. So you're looking at me and saying, oh, you took a labor category and you're saying it's not really labor. And I'm saying exactly right. It's like an investment. Okay, we're going to treat the input of techies into the firm as something that does not contribute automatically to output today, but it will contribute to output tomorrow, but not in terms of factor augmentation, or rather in a Higgs neutral augmentation fashion. Okay, it's going to happen with a lag. Okay, actually, we're not the first to make this kind of assumption. Most of the literature makes this assumption. Okay, Doroshevsky and Jamandr, when they studied the impact of R&D on productivity, it has this exact same structure. De Loker, Bloom, Sadun, and Van Reenen, so on and so forth. In fact, the whole intangible capital calculation, which is typically not done at the firm level, but at the industry level, follows the exact same approach. Permanent inventory method for computing this intangible. One of the components of this is indeed wage bills spent on engineers and innovators. Nevertheless, we're going to examine the sensitivity to this assumption as we go along. All right. So what is the framework? What is this production function framework? So there are two pieces, two important pieces. I'm keeping the notation here to the bare minimum. So what we observe in our data, sadly, is not quantities of output. Actually, observing quantities of output creates a whole kind of headache. It's an even bigger headache. Sometimes I think it's better not to see quantities of goods, of products. But what we observe in our data is sales. Okay, that's revenue. And we're going to associate revenue to what? To a demand shifter. This is your B, modulated by a parameter that takes into account, the demand elasticity. Productivity is going to be omega, okay? And the production function is F. Everything here is in logs, okay? So there's also an implicit assumption that productivity is log separable from what is sometimes called the transformation function, the F, okay? Rho is a parameter that modulates the demand elasticity, okay? The other piece of the structure is this controlled Markov approach, okay? There's this G function that associates the productivity tomorrow to what? To the productivity today, firm level decisions today, and unexpected things, okay? Which are assumed to be orthogonal. Now, if you're a macroeconomist, this looks very, very natural. Firms build expectations on what's going to happen tomorrow. This is based on their information set today. What do they know today? They know their productivity today. They know what decisions they make today. What will happen tomorrow is partly influenced by that, and everything else is what they couldn't predict. Otherwise, they would take that into account, right? Now, labor economists sometimes don't like this structure. And they tell me, okay, but this is not going to give you the average treatment effect, right? Because labor economists are obsessed with treatment and control. And so, and to them, I say, absolutely, this is not the average treatment effect, because if you sprinkle techies across the economy, you will get something, and this is not what we are measuring. We are measuring the transformation of the employment of techies for the firms that actually chose to do so. Okay? If you want, this is a local average treatment effect, or the effect of the treatment on the treated. Okay? This is the precise interpretation. Now, our objective is to characterize this G function, right? Because the techies are going to show up in this Z variable or vector. Now, the problem is that in order to do that, you need to calculate, you need to infer the omegas, which are not available. They're not in the data. So there are two ways to do this, or either you use a methodology that first, in a first step, identifies all the omegas in your data, and then you regress, or you do it all together, okay? Now, we're actually going to do both. Now, the main challenge in this literature is something that's called transmission bias. Why is this a hard problem econometrically? Well, because I don't observe omega. If you look at equation number 1, the firm does know omega. And so when the firm observes an omega, it's going to adjust its demand for, in particular, variable inputs, let's say materials. And if you think that labor adjusts freely, then labor as well, okay? And that will give rise to spurious correlation in that regression because omega is unobserved. It's just like an omitted variable bias. In the jargon, this is called transmission bias, okay? And so the econometrician does not observe omega, and you need to control for that somehow. And that's why the G function is so important. Okay, very, very quickly on methodology. Virtually everything that's been done in this productivity estimation literature is in the process of being debunked, not by me, but by Gandhi, Navarro, and Rivers, and Ackerberg himself, who has contributed to this literature in a big way. So what are the problems? Two problems. GNR show that there's a weak instruments problem. So, you know, in a two-stage squares, weak instruments is very, very bad. It gives bias, non-convergence, all the bad things that you hoped that two-stage squares is going to avoid and solve. Ackerberg actually, in a relatively, it's an ongoing piece of work, shows us there's an even more fundamental problem in this control function approach. Okay, the Oli-Pecas, Levinson-Petrin, ACF, all that stuff. They actually show a very surprising result that the GMM estimator that is involved in estimating the production function actually gives rise to multiple solutions. And in fact, these are global solutions. They're not even like, you can't even rank them. Okay? And worse, one of those solutions is what you will get if you just ran OLS. And why is that particularly disturbing? Because what do people do when they start a numerical search? They need to you need to provide initial values. And where do you get those initial values? You get them from an OLS regression. And I've asked many people that have done this, and they say, oh, and that's what we do. And after all the dust settles, this control function approach and the GMM gives me results that are actually almost undistinguishable from what I would get from OLS. And Ackerberg is telling them, yes, but that's not the right answer. Okay. And so in a paper that I've recently penned with other co-authors in Paris, we show that these are indeed serious problems. Propose a solution for some of them. And so we're going to opt for two different estimators that are a little bit less popular in the literature because they're relatively new. So one is the Greco-Lee and Zhang estimator. I'm going to talk about that very briefly, show you why it has some advantages and also its disadvantages. And then an extension of the Gandhi, Navarro, and Rivers estimator, okay? Both of these estimators are going to acknowledge the fact that we don't actually observe quantities, okay, that we observe only revenue. And I'm going to discuss quickly the pros and cons. Just want to be on time. When do I need to stop? At 3:30? Okay. I'll go very quickly. Actually, just take a look at the last bullet in the interest of time, because I want to show results rather than talk about nerdy methodology. GLZ, the Greco-Lee and Zhang estimator, has the advantage of actually being consistent with the data that we have. Okay? But it restricts, it has an assumption on the structure of the production function. It assumes that it's constant returns to scale, a CS production function. Okay, and on top of that, it requires that labor is a variable input. So labor adjusts freely. In the context of the French labor market, this is not a very appealing assumption. And actually, it's not appealing in any labor market, because even when in the US where you have employment at will, it's not like firms are going to adjust labor to meet its marginal product every single period, because there are all kinds of phenomena like labor hoarding and learning on the job and all, and firm-specific human capital, okay? So, but GLZ is much more tailored to the quality of the data that we have. Contrast, the GNR model is much more general. Okay, we don't need to make any assumptions whatsoever. Okay, about the production function, about labor, doesn't matter at all. But it requires two data compromises. One is that it requires that we know material inputs and quantities. Nobody knows material inputs and quantities, except for GLZ. That's why GLZ is very, very valuable, I think. It's an underappreciated estimator, in my opinion. And the other compromise that we need to make with GNR is that because it identifies the influence of demand on output only from time series variation, we don't have many years, we can't identify that. So you'll see in a bit what the consequences of this are. So, but in the end, we're going to perform the entire analysis with GLZ and two versions of GNR. One that assumes that labor adjusts flexibly, and one that assumes that it does not. Okay, which is much more in line with. It doesn't mean that labor doesn't adjust; it just doesn't adjust immediately. Okay, we don't make any assumptions on the adjustment process. So data, very quickly, we're going to merge the administrative data sets for France. We're going to look at 17 private sector industries in this sample of 9 years. Some data cleaning. And we're going to measure the techie input as the share, as an intensity. So it's going to be the share of the wage bill of the firm that is devoted to the ex-techie wage bill that is devoted, well, you take the wage bill of techies and you divide it by the wage bill ex techies. Okay, it's a measure of intensity, and we're going to take into account both the extensive margin, so firms that have techies versus firms that don't, and also within the firms that have techies, an intensive margin. So we're going to have both of these things. In other words, we're going to have an indicator variable for the presence of techies, and then and then also the share itself. Okay. So a little bit of descriptives on the data. What you saw before are just like the entire French economy. Okay, now we're going to look into firms. We're going to look at the incidence of techies across firms. And what do you see? You see that most manufacturing firms employ techies. Okay, so you see in general, almost 72% of manufacturing firms employ some kind of techie. There's some variation across different categories. Much less in non-manufacturing. And you see that there's a lot of variation within the intensive margin. And it's exactly this extensive margin, 0 to positive, and within the positive, the intensities that permits us to identify what we identify later in the econometrics. In other words, there's plenty of variation. Okay? All right. So when you do this, I'm not going to show you, in the interest of time, the production function estimates that you get from these two methodologies. They're reasonable. They're actually very reasonable. They're very reasonable in all kinds of dimensions, but importantly also, kind of in a curious way, industries where you think that there's more product differentiation, so where you find lower elasticities of substitution, that's consistent with theory. Industries where you think that there are lower margins and less product differentiation, and products are relatively more homogeneous. This is where you find the big elasticities of substitution. A lot of things in the production function and demand identification part of the estimation makes a lot of sense. And then what do you do? So in GLZ, it happens in two steps. First, you identify all the omegas, because GLZ is a particular estimator that buys you that possibility. Okay, and then you pool all these omegas, and you run these types of regressions. So you have industry by year fixed effects, lagged productivity. So this is the G function. Okay, and then you have these indicators for techies. With GNR, the estimation of this equation happens together with the estimation jointly in a big fat happy GMM procedure together with the identification of the production function itself. Okay. The difference is, as you can see, that in GNR, we give up the possibility to identify the omega, the rho parameter. We do not strip out omega. Sorry, not omega. We do not strip out, or we don't strip out omega from rho omega. Okay, because we can't identify rho in a precise manner. Okay, because of the short time span. We have 9 observations for each industry. It's just not enough. And so qualitatively, the results are very, very similar. The numbers are actually modulated, and in fact, the impacts are smaller, which actually makes sense because these the beta that you would like to identify is modulated by rho, and rho is a number between 0 and 1. Okay, good. So here are the baseline results. Okay, I'm going to be on time. So here are the baseline results. So first of all, we show that techies have a positive effect on this productivity. Okay, you can see in column 1 and in column 5 that this extends only the extensive margin. And then you also allow the intensive margin. You can see that the extent, if you only allow an extensive, the extensive is really built of a real extensive and an intensive part. And the intensive part is important as well. Okay. Next, we split these techies into the 3 categories. Okay. And what you see, I think it's enough to compare column 3 to column 7. You see that all 3 categories contribute to productivity, but to different extents. Okay. And in particular, the R&D category doesn't contribute in a precise and a statistically significant way, or not highly statistically significant, to productivity in the non-manufacturing sector, which makes sense. Okay, makes sense a priori. There are fewer people there, fewer R&D techies there, but even the ones that are there, their impact is not so big. It's not so salient. And that makes sense because the kind of productivity enhancing activities in non-manufacturing don't actually go through R&D, at least in terms of an accounting perspective. Okay. Then we want to quantify these regressions. So what we do this in 2 ways. One way is to say, I'm going to compare a firm that doesn't have techies to a firm that has the median level of techies of each type, of each category. Okay. Another way is to say I'm going to compare 2 firms that have techies, but one of them is at the 1st quartile and another one is at the 3rd quartile. Okay, so the interquartile range. And you can see that a firm that, for example, a firm that has techies at the median level versus a firm that doesn't have techies. What is the? I can't see the number there. It's a 1. Sorry, it's 4%. It's 4%. 4% point more productivity year on year. Okay. If you look to panel B, this implies a cross-sectional difference in productivity of almost 60%. Okay. How do you get this cross-sectional productivity? The implication, you assume that this is going to be the characteristic of the firm forever. Okay. And you compound that through time, or you do the algebra and you realize that all you need to do is to take that coefficient and divide it by 1 minus lambda, lambda being the persistence parameter from the regression. Okay. All right. And so you see that another thing that you see here is that other techies are actually carrying most of the effect. Okay, the overall effect of techies is happening a lot through these other techies. The marginal impact of R&D and ICT on productivity is lower. You also see that there's some differences in the intensive margins in non-manufacturing, but these differences are mitigated somewhat once you take into account the long run effect. So the bottom part of the table is the more interesting one, pertains to firms that have techies versus firms that don't. Okay. Another thing we do is we say, okay, we don't expect the impact of techies to be homogeneous for all firms. And so we allow now for the techie vector, okay? So T here is going to have both the 0, 1 and the intensive margin, and the intensive margin is going to be evaluated at different percentiles. And we're going to evaluate this, we're going to add to the regression an interaction term with the lagged productivity, and we're going to evaluate this at different percentiles of productivity. And so you have this matrix, okay, 3x3 matrix for manufacturing and non-manufacturing. And there's a common thread here. The overall effect of techies is larger for firms that were ex ante more productive. This can, if this process is persistent, then this can give rise to a fanning out of the productivity across firms. The bigger firms are seeing bigger effects, and they keep on growing. The smaller firms that have techies do see positive effects, but they're smaller. It increases productivity dispersion, if you want, productivity inequality. This is true in manufacturing and non-manufacturing. And that and we also see that the marginal effect of techies declines with lagged productivity. So this you see from going from 20, skipping down rows. Okay, so the difference between the first and the second row and the second and the third row, so the difference between the third and the second is smaller than between the second and the first, but those differences shrink as you go from left to right when you have more productivity. So there's a kind of this diminishing returns to techies as lagged productivity increases. The marginal return is smaller, but the overall effect is bigger. Okay. How do you get that? You get that from an extensive margin that is bigger with lagged productivity, and an intensive margin that is smaller with lagged productivity. That's the regressions that underlie this table. That's what they say. We do a lot of sensitivity analysis in this paper, okay? So I told you in the beginning that we make this structural assumption that says, okay, these techies are not contributing to contemporaneous output, okay? And so we say, okay, maybe some people don't like this assumption. So we say, okay, suppose the techies do associate. Suppose that there's a parallel world in which techies contribute only to productivity in a contemporaneous way, just like labor. Okay, if that were the case, then they should not have an effect in the G function, the control Markov function. But this we can reject. This is flatly rejected. So at the minimum, we can say techies don't contribute only to contemporaneous output. That's something that we can definitely reject. Clearly, I don't know if it's clear or not, but we can't actually make the stronger statement that that our model is rejects adding techies to contemporaneous output completely. Okay. But what we can reject is that techies contribute only to contemporaneous output. Am I making myself clear? Okay, good. We have tables if you want to see. We can allocate other. So we have this concern that this group of other techies, which econometrically seems to be really important, it's kind of a heterogeneous group. So you have all kinds of engineers there: quality control, chemical engineers, civil engineers, waste management engineers, all kinds of stuff. Maybe you don't like these assumptions. You want to have only the technology people. You want to have the R&D people and the ICT people, people that we really can identify either with clear patenting and innovation or one clear technology. So we say, okay, we put all those other techies into labor and we treat them as labor, and the results qualitatively don't change. In fact, we get bigger effects for R&D and ICT. It's not quite like an omitted variable that a bias, but it goes in that direction, has that flavor. We're not shocked that we get bigger effects. You can estimate this control Markov with a richer process for lagged omega. We do that, no big change. All the results that I've talked about so far are based on the GLZ. We get qualitatively the same story with GNR, except that the magnitudes are slightly different. And in particular, because of that row, once you take into account that this row is smaller than 1, then you understand why all the coefficients are as statistically significant as before, but economically smaller, because they are not talking about Q productivity, they're talking about revenue productivity. And importantly, maybe this is a table we can show. How do I show that table? How do I go to that table? The last table, the last link, management. Yeah. So what we do is we say, okay, we're going to show you that adding management to the regression. Okay, so in fact, just saying, okay, we're going to pay homage to Nick Bloom and John Van Reenen that we like and love and appreciate their work. It doesn't. We're not saying that management doesn't contribute. Actually, in manufacturing, it's not so clear. But it doesn't affect hardly at all our results on techies. There's something different. Okay, firms that have a lot of management input, maybe they have a productivity effect, maybe they don't. Maybe this methodology is not a good one to evaluate those things. But at least as much as we are concerned, it really doesn't affect the impact on techies, comparing column 1 to 2, column 5 to 6. Okay. This is cut out of a table that has many other columns, so I'm just giving you the main idea. We can, Shai, if you can go back, thanks. And so I'm done. So what do I like you to take away from this talk? Okay, so first, the techies are important determinants of firm-level productivity. I think every time I present this paper, nobody is shocked by this statement. Some people take an aim at the methodology, at an assumption, at some data decision that we made. Nobody is shocked. What I want you to take away from this, nonetheless, is that this is something that is important not only in manufacturing, but also in the non-manufacturing sector, which is the bulk of our economies today. The effect is going beyond R&D. This is not just about R&D and patenting. It's also about these other people that, at least in principle, are not doing R&D, at least in terms of an accounting of what the firm reports to the French authorities. Okay. Now, R&D may be the single most important thing that will drive the frontier of technology. But if you're not at the frontier, maybe you don't necessarily need to do R&D in order to see productivity growth. You can have other types of techies that are maybe adopting, right? So you can imagine a mechanical engineer adopting technologies that were developed by an R&D engineer in the same industry, right? Or in a different industry for that matter. Okay? And it has some implications for education policy, we think. It calls for a trade-off between basic research, or maybe the elite research, and people that can just basically do the job. So if you work in a French university, you know that quality IT support is rare. I'm actually lucky, but I know other places where this is a problem. Okay. And so there may be, I'm happy to hear that France is actually investing in such programs. I actually think it's super, super important. But the paper does demonstrate that there are positive effects coming from both what you think of as R&D, like, the people that are really inventing the next new thing, versus people that are taking those things, bringing it into the firm, adapting it, maybe modulating it, teaching people how to use it. And so I think I'll stop there.
Thank you. Thank you very much, Ariell. Very, very interesting and perfectly on time. I'm pleased to open the floor for questions. So attendees, you're encouraged to ask questions through the Q&A feature in Zoom. Should you wish to speak, you may raise your hand, as I said before, and we'll assist you to intervening. And the guests in the room, you can just raise your hand and push the microphone button. Any questions from, okay, Antoine?
Thanks for this super interesting work. I have a couple of of questions. So first question is on sort of more the endogeneity part. So what you're saying is that this positive impact of techies into firms on productivity is not reflecting self-selection. It reflects really the fact that when you bring more techies into those firms, it really upgrades the productivity of firms, which I think is a very interesting result. Now, I think that the selection aspect, the self-selection aspect, is also very interesting And I wonder if the fact that you have different elasticities for different types of firms, so it also across different industries, so between manufacturing and non-manufacturing, may reflect some form of allocation issues, so eventually misallocation, and whether it can inform about the kind of aggregate productivity gains that you could get by changing that allocation, and so how it could impact welfare.
Okay, so just to be clear, the self-selection effect, the self-selection is controlled for by the presence of lagged productivity. Okay, so so that's kind of like what the methodology buys you. Now now what can we study this self-selection? Does it indicate something? I have to be honest, I didn't think about it that way. When you look at the table that quantifies the regressions, you see actually that over the marginal effects may be different across tasks and across sectors, but the economic effects are not drastically different. So I'm not sure how much I can make out of that, but I think it's there can be something that can be gleaned from this for sure. I think if you think, in other words, if you think that the bang for the buck, so to speak, for ICT is bigger in non-manufacturing, you want to incentivize them to go to non-manufacturing than to manufacturing. It seems that that's what's going on already. What we know, and we don't show here, is that especially for this other group, this heterogeneous group, we actually know that, as I was mentioning before, civil engineers are in construction mostly. The chemical engineers are in chemical sectors. So there's already some kind of sorting, and it's actually it's a complicated question, but maybe for at least for the ICT, we can make some statement about where the marginal returns are higher. Maybe want to push some IT people. But I personally think that the bottleneck is really the quantity overall, less so who goes where. Because these people, if you're an IT engineer or IT technician, you're comparing wages across sectors. You don't really care which sector you're going to. And if your wage reflects even vaguely your marginal productivity, which to a large extent we think it's right, then this is maybe not be the first order problem, but it's definitely something we can think about.
I think I was going to ask basically the same question, but it's a slightly different type of sorting, I think. So I don't know these estimators, but do they account for like positive assortative matching between, is it just that you get high ability techies going to high productivity firms? Like, are you controlling for that in some way? And so like, how do you interpret basically the coefficient? Do you think of it as like the causal effect of additional techies on productivity? And therefore, I mean, from the like policy conclusion you had at the end, I'd say that probably like that would be the policy conclusion takeaway from that, right? Or is it that there's some matching between, high productivity firms and high ability techies, and we should instead focus on that? And thanks as well. It's really interesting.
Yeah, thanks for the question. So so the methodology tells you, here's what happened. So the firms that engaged in hiring techies, this is what they got in terms of productivity. That's at least in principle, what it's supposed to tell you. In terms of the quality sorting, first of all, the way we measure the techie input is in terms of their wage bill. So we think that takes into account quality issues. So you're a good techie, I'm a lousy techie, you're paid more and I'm paid less. So that's kind of like taken into account into the intensive margin. And also if you are in a bigger firm, in a better firm, you're paying everybody more. That's in the denominator. So part of that is taken into account in our measure. Do we actually think that there's kind of like a Kramer O-ring thing going on where the better people go with the better people? In reality, I think that that's true. But we can't speak to that very easily, at least in this paper. Do I think that that's something that happens? Absolutely. And you know, there are a lot of papers about spillovers and within firm spillovers. So you're smart, but just like in education, right? You're a smart kid. You join a class of smart kids. You leverage your ability more than if you're allocated into a class with lower quality students or less motivated students. So similar with techies, our tech is going to have a better effect in firms that work better. I'm absolutely sure that that's true, and it's kind of like a little bit of what we're picking up with this heterogeneity across productivity, ex ante productivity of firms, right? The bang is bigger in more productive firms ex ante.
Rudy, and then we'll have a question also online.
Yeah, thank you for the very interesting presentation. I have a question exactly on this heterogeneity across firms. I was wondering if this reflects ex ante productivity, or this can reflect as well to some extent firm size. So whether this heterogeneity between firms of different productivity, for instance, you will get it as well in firms with like relatively similar size. And if that's the case, what it can reflect, whether it can reflect, for instance, the complementarity with other factors within such firms. Yeah.
So the methodology does not permit us to put firm size. We can only put firm productivity, but we know that more productive firms are larger. That's kind of like how it's identified, right? So I don't see a huge distinct. You may, and we actually have that in our data. When you do the analysis of productivity and size across firms, it's not a one-to-one mapping. There are highly productive firms that remain small because they haven't figured out their demand yet, right? And that's something that the methodology allows to happen to some extent, right? But by and large, it's the bigger firms, right? And then you may be concerned about market power effects and all kinds of other things that size entails. And then the interesting question is really, why do bigger firms, more productive firms, see a bigger effect of hiring these techies? And indeed, I mean, this is something that we mentioned in the draft at some point. We do think about complementarity, but not with the other factors, right? It's more like standing on the shoulders of giants, right? If the giants are bigger, then you see farther, right? So it's complementary. Think about this as just like in macro and growth is an AK model, right? The marginal effect is bigger when the bank of knowledge is larger, right? So that's how I think about it. Not particular complementarity. In a previous paper, we actually try to do that in a more. We try to talk about whether these techies are more complementary to skilled and unskilled labor, and with a much more elaborate estimation procedure that we actually developed. But that's different from what I'm saying here today.
There was a question online which tells, of course, thanking you for the very interesting presentation. The question is about your key education policy message, whether it is more the trade-off really about education fundamental researchers versus applied engineers within tech, or it is not more between tech STEM higher education and non-STEM curricula?
A good question. It's more within the technology class. So you can. I mean, you know, in the context of France, do you need more? There are how many engineering schools in France? Upwards of 300, I think. And so the state supports a lot Polytechnique and doesn't support hardly at all anything outside of the top 10, maybe. I'm just saying that. I don't actually know if that's true. So what we're finding seems to suggest that there needs to be a balance between supporting the very best that are going to create the new algorithms, the new artificial intelligence, all that new stuff. But at the end of the day, on the other hand, there are all these firms that want to use that stuff. And if they don't have people that can implement, it's actually not that straightforward to implement artificial intelligence within your firm. You need the people, right? This is like this is the big thing today in technology, right? You actually need the people to bring it into the firm, adopt it, adapt it, teach people how to use it, and so on and so forth. It actually doesn't run completely automatically. And so so the distinction here, and it's not like we have something concrete to say about it, right? And we're not going to make a public policy statement, oh, you are over subsidizing Polytechnique. Probably that the opposite is true. But what we are saying is that trade-off needs to be taken into account. And it's not an obvious trade-off to make.
Any other questions in the room? Elder.
Thank you. So my question was about your assumption about the techies themselves not going directly into the production function. So do you include just the number of workers, non-techie workers, or the wage bill? And is there other occupations that also shouldn't be included, like for the same reason as techies? Thank you.
So so all the other labor is in labor, and it's counted in hours, actually, not in numbers of people. We did try at some point counting other people in terms of wage bill. There are papers that suggest that may be a better measure. It didn't make a qualitative difference on our results. Surprisingly, we thought it's going to wreak havoc on what we do, but it didn't. And so are there other occupations that shouldn't be? So we tried a bunch of things, actually. So we tried with management, as you saw. So I showed you part of a table, part of a general treatment of management, part of this because we got pushback from John Van Reenen, and not unjustly. Okay, he said, okay, you need to take us head on. Why don't you? And I said, yeah, we'll do that. And so we did. And so that was an absolute failure for the management. So what our conclusion from that entire analysis was that actually management contributes to output today, not to output tomorrow. And if you think about it, yeah, maybe some decisions of managers are going to influence investment decisions and so on, all kinds of things. But it's much more associated with what's happening within at least the tax year, right? And the balance sheets of the firms, because that's the data that's identifying this. Maybe a longer term perspective would give us a slightly different result, but then you need different methodology. And so we also tried with so when we talked about management, we thought about it in a broad way. So the regressions that you saw are treating like the cadre of management. But then we said, okay, what about just white collar workers, or people that do middle management and so on? It gave us either similar results that indicated that they don't belong in the control Markov, or the results were very unstable, in the sense that you change a little assumption, you change a little bit, you tweak a little bit the methodology, the results change in a big way. So we think that that's a good indication that our choice for techies is not a bad one. Do we think it's the only way of thinking about things? Absolutely not. There are other ways of doing this. But we actually spent the better part of September, October, and November actually working on that, and we couldn't get anything consistent. Okay, and importantly, every time we did this, the impacts of our techies didn't change in a qualitative in a qualitative way. Sometimes the magnitudes of the coefficients did change. I'm not going to say, I'm not going to lie about that, but the main story didn't change. So yeah, maybe there are other occupations. I'll take one last comment on that. When you start doing that exercise, then you may run into a complete collapse of the concept of a production function, because where do you stop, right? And so that you need to actually decide on something. I stop there.
Thank you, Ariel. So there is another question from online. It says, based on the presentation, it seems that technological extension programs are supported by research. Therefore, I ask online, could micro and small business in the commerce and services sector, non-manufacturing, that participate in these programs, which do not necessarily require investment in machinery, achieve an increase in productivity through the appropriation of new knowledge? And if so, what would be the triggers for growth?
So if I understand the question correctly, these are programs that incentivize smaller firms in non-manufacturing sectors to invest, to train workers in technologically related skills. So I mean, the interpretation of our results is that yes, this is good. They don't necessarily need to be at the frontier. They don't necessarily need to have even engineers. They can do this at a lower level, these technicians. And but the results do indicate that it would be important for them to hire at least someone that is technically trained to help bring in that knowledge into the firm. The descriptive results indicate that this is actually happening, right? When the firms that do these types of training, I'm not sure if what's in the ICT survey corresponds to that program, but it seems to be the case that ICT techies are highly correlated with ICT skill training in firms in France.
Any other questions in the room or online? Olivier.
Thanks. Thank you for the presentation. Just a minor clarification, maybe. Is there, I mean, managers are managers and techies are techies. And I was wondering whether there are managers that are techies that have STEM education or these kind of things, because maybe adoption like also needs someone that understands what the firms do, no? I don't know if
So sorry, I'll repeat. So the managers that are managers are rarely have STEM education, which doesn't imply that they don't understand what technology can do, right? They're probably very tech savvy, right? But it doesn't mean that they understand the technical underpinnings of the technology. And so that's the distinction. So I think I'm answering your question. No? Okay, so whether we control them.
yes.
So in the main results, these people are associated with labor input, but in the auxiliary results, we put, when we say manager, these are the managers. And they don't seem to have as you saw, they don't seem to have you would think that they would have an impact on productivity and hence on future output. The results were not quite there. And importantly, maybe all that's happening, but it's not affecting our main results on techies. So maybe that's happening, but the techies story is also happening. We're not saying, this is not a paper that says everything that has been done hitherto is wrong, apart from the methodological point of, GNR and Ackerberg and people. What we're saying is that here's another channel, and it may be it may be important. Maybe you want to pay attention to this. That's it.
Any other questions?
Yeah, just
I don't know if it makes sense, but basically I'm trying to think if the amount of time that a techie spends in a firm matters here, and how quickly they roll over to other firms, especially given that I assume that techies are looking, like you said, the higher the wage, they're looking to move to other industries if there's a higher wage, if that matters at all in this situation.
So our measure of techies takes into account the within firm quality. So the firm, the assumption, and it's not a crazy assumption, is that, you know, if you learned over time, you will be paid more. And this is showing up in our intensive margin, the analysis of the intensive margin. Now you're talking about movements of these techies across firms. Do they bring knowledge with them? So there are very few papers that actually look at that. There's a Tambe and Hit paper about IT. It's a very specific survey of IT engineers, and they do show that there are IT spillovers. So IT engineers that work in one firm and move to another firm, they carry with them something good beyond, presumably, beyond their inherent ability. So do I think that that's something real? I definitely think that that's something real. Can we see that in this paper? No, that requires very different methodologies. It requires tracking people over time. But luckily in France, there are data sets that do that. You have the database panel, where you have 1/12 of the workforce, right? So that's quite a bit, actually. You can track 1/12 of the workforce over their entire career. That's pretty amazing, to my taste. Okay.
Probably we would have time for the last question, if there is any online or in the room. Well, okay, there you go.
I have a funny one. So it's not only that kind of managers do not change this relationship, but actually you find like a statistically negative effect, no, on on productivity. How would you interpret that?
The interpretation is that's a misspecified regression. We don't actually, in the paper, we're very careful. We don't say managers have a negative effect. We actually are very careful in saying that result implies a misspecification of the regression. Yeah. It's because that regression, in particular, that regression is a regression where the managers show up also in labor. I didn't mention that, because if you see that it's the same sample as when they are not appearing in the control Markov, the precise same sample. So all we're doing is saying we're going to take the main results and add erroneously the managers to the control Markov. And what do you get? You get junk. And in particular, you get junk that does not permit you to say, they contribute not only to contemporaneous output, they also contribute to productivity growth in the next period. That's a more precise statement that describes those results.
Okay, I think there are no other questions online, and was a very, very rich discussion and super interesting presentation. Let me just say a few words to close, just to express really our gratitude to Ariell for his time and the great presentation today. It was super interesting with a very lively discussion, which I think brought a lot of insights, also very much policy relevant. Let me also thank Paul Cusson very much for the introduction in the opening remarks, and thank all of you, the audience that have attended here in the room and online for the participation and the questions. Let me wish everyone a very pleasant afternoon if you're here in this time zone, and looking forward to welcoming you back at our next PI seminar. Thanks all.